Welcome to our Polyskill YouTube channel. Hope you are all doing good. Another day, another skill. In this session we are going to see new topic. Hope you enjoy this informative video. Let's begin this session. Subscribe to our YouTube channel. Press the notification bell. Like, comment and share this video with your friends and family. For better understanding, please watch the video until end.
Natural rubber tree, also known as Hevea brasiliensis, is a species of tree native to South America, specifically the Amazon region. It is the primary source of latex, the milky fluid that is used to produce natural rubber. The tree is now widely cultivated in tropical regions around the world, including Southeast Asia and Africa, due to the high demand for rubber products. The natural rubber tree can grow up to 100 feet tall and has a grayish-brown bark. The leaves are evergreen and typically have 3 leaflets, each about 3 to 6 inches long. The tree produces small, greenish-yellow flowers that are pollinated by insects. The latex is harvested by tapping the tree, which involves making small incisions in the bark and collecting the milky fluid that flows out. Natural rubber is used in a wide range of products, including tires, gloves, footwear, medical equipment, and household items such as erasers and rubber bands. The demand for natural rubber continues to increase, leading to concerns about the environmental impact of rubber production and efforts to develop more sustainable methods of cultivation. The history of natural rubber dates back thousands of years, with evidence of indigenous people in South America using latex from the rubber tree to make balls, footwear, and other items. The Mayans and Aztecs also used rubber for a variety of purposes, including waterproofing clothing and making containers. It wasn't until the 19th century that natural rubber became a valuable commodity on a global scale. In 1839, Charles Goodyear discovered the process of vulcanization, which involves treating rubber with sulfur to make it more durable and less sticky. This led to the development of a wide range of rubber products, including tires, gaskets, and hoses. The high demand for natural rubber during this time led to the establishment of rubber plantations in Southeast Asia, particularly in Malaysia and Indonesia. These plantations were established by European colonial powers, and their success depended on the exploitation of indigenous labor. In the 20th century, the development of synthetic rubber reduced the demand for natural rubber. However, natural rubber remains an important commodity, particularly in the production of tires, and the industry continues to face challenges related to sustainability, labor rights, and environmental impacts. There are several varieties of the natural rubber tree, but the 2 main types are 1. Hevea brasiliensis. This is the most common type of natural rubber tree and the one that is widely cultivated for commercial production. 1. It is native to the Amazon region of South America but is now grown in many tropical regions around the world. 1. Hevea brasiliensis trees can grow up to 100 feet tall and typically have a single trunk. 2. Hevea guanensis. This is a less common variety of natural rubber tree that is native to the Guianas region of South America. 2. It is similar to Hevea brasiliensis but has smaller leaves and produces less latex. 2. Hevea guanensis is not widely cultivated for commercial production. There are also several hybrid varieties of the natural rubber tree that have been developed through crossbreeding, such as GT1, RRIM 600, and PB 260. These hybrid varieties are typically bred for their disease resistance, productivity, and latex quality. There are several other types of rubber trees, but they are not used for commercial rubber production to the same extent as Hevea brasiliensis. These include 1. Ficus elastica. This is a type of tree in the fig family that is native to Southeast Asia. 1. Its latex was traditionally used to make rubber, but it has been largely replaced by Hevea brasiliensis. 1. Ficus elastica is now primarily grown as a houseplant or ornamental tree. 2. Para rubber tree, Hevea passiflora. This is a species of natural rubber tree that is closely related to Hevea brasiliensis. 2. It is native to the Amazon region of Brazil and produces a similar type of latex. 2. However, it is not as widely cultivated as Hevea brasiliensis. 3. Landolphia. This is a genus of rubber trees native to Africa. 3. Their latex was traditionally used by local people for making rubber, but they have not been cultivated on a large scale for commercial production. 4. Manilkara. This is a genus of trees native to the Americas and Asia that produce a type of latex that can be used to make rubber. 4. However, they have not been cultivated for commercial rubber production due to the low yield and difficulty in processing their latex. Overall, Hevea brasiliensis is the primary source of natural rubber for commercial production due to its high yield and quality of latex. Balata and Gutta-percha are two natural materials that are related to rubber but have different properties and uses. Balata is a natural latex that is derived from the sap of several species of trees in the genus Manilkara, which are native to South America and the Caribbean. Balata is similar to natural rubber but has a higher tensile strength and is more resistant to abrasion and tearing. It was traditionally used to make golf balls, shoe soles, and other products that require a durable and flexible material. However, Balata has largely been replaced by synthetic rubbers and plastics in modern manufacturing. Gutta-percha is a natural latex that is derived from the sap of several species of trees in the genus Balatta, which are native to Southeast Asia. Gutta-percha is a thermoplastic material that softens when heated and hardens when cooled, making it ideal for molding into various shapes. It was traditionally used in dentistry for filling cavities and making impressions, and in electrical insulation for its non-conductive properties. However, gutta-percha has also been largely replaced by synthetic materials in modern manufacturing. Both balata and gutta-percha are sometimes referred to as gums or resins, due to their similar appearance and chemical composition. However, they have different properties and uses compared to natural rubber, which is derived from the sap of the Hevea brasiliensis tree. Balata. 1. Balata is a natural latex that is milky white in color and has a similar chemical composition to natural rubber. 2. Balata is derived from the sap of several species of trees in the genus Manilkara, including M. bidentata and M. huberi, which are native to South America and the Caribbean. 3. The harvesting of balata involves making incisions in the bark of the tree to allow the sap to flow out, which is then collected in cups or buckets. 4. Balata has a higher tensile strength and tear resistance than natural rubber, but is less elastic and has a lower rebound resilience. 5. Balata was traditionally used to make golf balls, shoe soles, conveyor belts, and other products that require a durable and flexible material. 6. However, balata has largely been replaced by synthetic rubbers and plastics in modern manufacturing due to the high cost of production and the availability of cheaper alternatives. Gutta-percha. 1. Gutta-percha is a natural latex that is brownish-yellow in color and has a different chemical composition than natural rubber or balata. 2. Gutta-percha is derived from the sap of several species of trees in the genus Balatta, including P. gutta, which is native to Southeast Asia. 3. The harvesting of gutta-percha involves making incisions in the bark of the tree to allow the sap to flow out, which is then boiled and molded into various shapes. 4. Gutta-percha has a thermoplastic property, which means it can be softened by heating and molded into various shapes before hardening when cooled. 5. Gutta-percha was traditionally used in dentistry for filling cavities and making impressions, and in electrical insulation for its non-conductive properties. 6. However, gutta-percha has largely been replaced by synthetic materials in modern manufacturing due to its high cost of production and limited availability. Some examples of rubber products that have been made from balata and gutta-percha. Balata. 1. Golf balls. Balata was historically used to make the covers of golf balls because of its high durability and elasticity. 1. However, it has largely been replaced by synthetic materials due to the high cost and limited availability of balata. 2. Shoe soles. Balata was also used to make shoe soles and heels because of its resistance to abrasion and wear. 2. However, synthetic rubbers and plastics are now more commonly used in footwear manufacturing. 3. Conveyor belts. Balata was used to make conveyor belts for industrial use because of its strength and flexibility. 3. However, synthetic materials are now more commonly used in conveyor belt manufacturing. Gutta-percha. 1. Dental fillings. Gutta-percha is still used in dentistry for filling root canals and cavities because of its non-toxic, non-irritating properties and ability to seal the tooth effectively. 2. Electrical insulation. Gutta-percha was used as electrical insulation for wires and cables because of its non-conductive properties. 2. However, synthetic materials such as PVC and polyethylene are now more commonly used for this purpose. 3. Molding compounds. Gutta-percha can be molded into various shapes and is still used as a molding compound for jewelry making, model making, and other applications where a durable and flexible material is required. It's worth noting that the use of Balata and Gutta-percha in commercial manufacturing has declined significantly in recent decades due to the availability of cheaper and more versatile synthetic rubber and plastic materials. However, these natural materials still have some niche applications in certain industries. While Balata and Gutta-percha are not native to India, they have been imported into the country for various purposes, including as raw materials for manufacturing. However, the production of these materials within India is very limited and they are not widely available. In the case of Balata, the tree species that produce this natural latex are native to South America and the Caribbean, and their cultivation is not widespread outside of these regions. The primary use of Balata historically was for the production of golf balls, but the use of synthetic materials has largely replaced Balata in this industry. Gutta-percha, on the other hand, is native to Southeast Asia and has been traditionally sourced from trees in countries like Malaysia, Indonesia, and Thailand. While there have been some attempts to cultivate Gutta-percha trees in India, the production of this material remains very limited and India primarily imports Gutta-percha from other countries. Overall, while Balata and Gutta-percha may be available in limited quantities in India, they are not widely produced or used within the country. Gutta Balata are derived from the Palaquium gutta and Mamusops globza trees, respectively, that are in the same botanical family as the rubber tree Hevea brasiliensis. For this reason, the potential for immunological cross-reactivity between the Gutta-percha and Gutta Balata used in endodontics and natural rubber latex, NRL, has been the subject of some controversy, because these products may be used in latex-allergic individuals. The objective of this study was to investigate the potential cross-reactivity between Gutta-percha, Gutta Balata, and NRL. Physiological extracts of 7 commercially available Gutta-percha products, raw Gutta-percha, raw Gutta Balata, and synthetic trans-polyisoprene were each analyzed for cross-reactivity with NRL in a competitive radioallergosorbent test inhibition assay. No detectable cross-reactivity was observed with any of the raw or clinically used Gutta-percha products. In contrast, the raw Gutta Balata released proteins that were cross-reactive with Hevea latex. We conclude that the absence of Gutta-percha proteins that can react with Hevea latex-specific IgE antibody supports the minimal potential for commercially available Gutta-percha to induce allergic symptoms in individuals sensitized to NRL. Because Gutta Balata is sometimes added to commercial Gutta-percha products, caution should be exercised if products containing Gutta Balata are used in endodontic care of latex-allergic individuals.
Thanks for watching. We'll see you with new informative video. Bye.